12, and we're going to continue talking about geometry. Specifically, we're going to get into congruence and similarity of triangles, and there will be some proofs that we will look at in this section or in this chapter. Um, it is important, I think, to be able to prove some of the theorems and all that we're going to do. I've told you multiple times that we're trying to build problem solving skills, a basic understanding of geometry and shapes and all of those things, triangles and quadrilaterals and all that. But we're also trying to get you to the point where you can think critically. And so the proofs is really where that comes in. So we're going to see some of that more in section 2 than in section 1. And so we need to start out with some very basic things. So as we talk about congruence and similarity, objects are considered similar if they have the same shape but not necessarily the same size. So, for example, when we look at a triangle, well, let's think about a square. You can think about that easily, I think. If you were to look at a square, you know that this square and this square have the same shape, right? Their angle measurements are the same. They're both squares, but their size is different. So we would consider those to be similar, but not congruent. And so when we talk about similarity, we use this symbol, this little squiggly line that represents similarity. We've mentioned before, if we're talking about congruent objects, we're going to use this sign. It's the equal sign with the squiggly line above it. And objects are considered to be congruent if they have the same shape and the same size. So we talked about in chapter 11 how if two segments have the same length, then we would consider those to be congruent. Or if two angle measurements have the same measure, then we would consider them congruent. Even though they're not the same angle or the same segment, we consider them to be congruent because they have the same shape and the same size. And so the same thing is going to be true when we talk about triangles and quadrilaterals. And that's really where we're going to focus in this chapter. So notice that congruent objects are similar. Similar objects are not necessarily congruent. They could be. If we had drawn these two squares here at the top, if we had drawn those to be the same size, then we would say, well, yeah, they're similar and they're also congruent. And so you need to understand there is a difference. Congruency means same size and shape. Similarity means same shape. Okay, not necessarily the same size. So, some definitions that we need to be aware of. If segment AB and segment CD are congruent, okay, that happens if and only if the length of AB, so this symbol means length of AB, is congruent to the length of CD. So this is length of CD. Okay, so when we talk about congruent segments, they're only congruent if they have the same length. And this if and only if statement means that this goes both ways. So if the segments are congruent, then that indicates their lengths are the same. On the other side of this, though, if the lengths are the same, then it also means the segments have to be congruent. And so this if and only if statement means that you actually can read this statement front or back, and from left to right or right to left, and it has the same meaning. If you don't see that if and only if statement, then it is not necessarily true to say it the opposite way. Okay, so just be aware of that. Now, if you look at the next one, the next statement here, it says that angle ABC and angle DEF, if they're congruent, or they are congruent, if and only if their measures are equal. Now notice here we used equal versus congruent. Congruent means same shape, same size. Equal means the same. Okay, so you can have two angles that have the same measurement, right? But those two angles are not necessarily the same angle. They just have the same measurement. And so that's what this says. And so, again, conversely, if their measurements are equal, then they have to be congruent. Okay, so we're going to use that as we go through the rest of this chapter. So, let's talk about triangle congruence. We would say that two triangles are congruent if all of their angle measurements and all their side lengths are congruent. Okay? So, you can see the statement there on the screen. Two figures are congruent if it's possible to fit one figure onto the other so that matching parts coincide. Meaning that if we take angle A here, and we take angle A prime, by the way, that little apostrophe symbol, we call it prime. If we were to take A prime and lie it on top of angle A, then what should happen is side length AB should have side length A prime B prime lying on top of it. And on top of angle B, you would have angle B prime. And then same thing with angle C. You would have angle C prime that would lie on top of it. And so then those sides would all lie on top of each other. So you would see this side angle, or side BC, B prime C prime, would lie on top of this one BC. And then this side A prime C prime would lie on top of this side AC. Now, when we talk about this congruency, it is important to make sure you have the letters in the right order. So if we're going to call this first triangle ABC, then we have to call the other one A prime, B prime, C prime. And the reason is because if you were to call it, let's say, triangle CBA, or C prime, B prime, A prime, that indicates that different parts correspond and that they would be congruent. So when you look at this notation down here, so look at this, the first letter, the first angle, and the first angle there have to be congruent. So angle A is congruent to angle A prime. And then angle B is congruent to angle B prime. And angle C is congruent to angle C prime. And it also means that there's segments between them. So segment AB, for example, is congruent to segment A prime B prime. Or side length, side BC is congruent to segment B prime C prime, and so on. Okay, so that notation is really important because it tells us what is lining up on top of each other. And so again, later on we get into the proofs, we may say, well, this side is congruent to this side, and so that means some stuff. And if you don't have those letters in the right order, then it messes up your proof, it messes up your logic. And so you have to make sure that you're careful about where each of those letters go. So, congruent triangles. Triangle ABC is congruent to triangle A prime, B prime, B prime. Written like this. You can see how that's written. If and only if, again, there's that statement. If and only if angle A is congruent to angle A prime, angle B is congruent to angle B prime, angle C is congruent to angle C prime, and then all those side lengths are congruent. So segment AB is congruent to segment A prime, B prime. BC is congruent to segment B prime, C prime. And segment AC is congruent to segment A prime, C prime. So when we talk about congruency, we're going to use this abbreviation a good bit. And it means that corresponding parts of congruent triangles are congruent. So we're going to talk about congruency here in a little bit. And when we do, we may say, well, these two triangles are congruent because if I can show some things are congruent, then we can take from that everything else is congruent. And so based off of the fact that their corresponding parts are congruent, then we can say, well, these triangles have to be congruent to each other. And again, it's going to be some logic that has to follow here for this to make a lot of good sense. But again, that notation is really important to begin with. All right, so what we're going to do is we're going to write an appropriate symbolic congruence for each of the following pairs. So for part A, we need to think about, okay, if we were to take this triangle in blue and we were to rotate it and put it on top of the original triangle, we would call the original triangle ABC. And so it's going to be congruent to this triangle in blue, but again, we've got to line up the parts that are congruent. So what is congruent to angle A? So this angle. Well, if you think about rotating, if you were to rotate it to the right, angle E would lie on top of angle A. And so we're going to say triangle E. And then angle B would correspond with angle F. And then angle D, which is the 90-degree angle, and angle C, which is the 90-degree angle, would also correspond. And so we're going to call this triangle EFD. Now, that may bother some of you if you're sort of OCD about things and want things to be in order and organized and stuff. That may hurt you because it's not DEF. Okay? But the reason it's not DEF is because if we start with the first one as ABC, then our corresponding parts have to line up. They have to be in the same order. So angle A and angle E have to be congruent, and angle B and angle F have to be congruent, angle C and angle D have to be congruent. And again, their corresponding side lengths too would be congruent. And so that is the way that we have to write this congruency statement. Now, go look at part B. So in this one, again, we have a triangle, we'll call it ABC. And by the way, the notation is to draw a triangle in front of it, and we say it as triangle whatever. So in this case, triangle ABC. And it's going to be congruent to this other triangle. But again, we need to think about, okay, what parts are corresponding? And so think about this. This should make some sense. You know that angle P and angle C have to be congruent, right? And hopefully you know from chapter 11 that the sum of all the angles inside the triangle are 180 degrees. And so if this angle A is 60 degrees, then angle B must be 30 degrees. So 60 plus 30 plus the 90 gives you the full 180. Well, once you realize that, in the other triangle, this angle R should be 60 degrees. And so now you can probably see, well, if I just flip that over, think about a line here where we flip the triangle on the right over to the one on the left, then we would see that angle R has to correspond with angle A, and angle Q has to correspond with angle B. Oh, Q, not B. Okay, so angle Q and angle B. And then angle C and angle P correspond. So again, it's not that the letters are going to be in alphabetical order necessarily. It's what lines up with each other. Now, if you wanted to call triangle ABC triangle CAB, well, you could do that, but then again, you'd have to reorganize your letters for the second triangle. And so Again, you can call it different stuff, but you just have to keep corresponding parts in the same order. And so there